Here's our topic. Here's our objective. And what this means is when we're given some data about a concentration and the rate of the reaction, the concentration of a product of a reactant, uh, we want to be able to tell you what the order of that reaction is. Now, there's a formula that we can use. This is the formula. The one stipulation is that you need to make sure that you're only varying one reactant, not more than one. All right. So choose your trials carefully. Now, these are the steps that I'm going to follow. All right. And it says there one reactant varies. And then there's that thing. You can get those if you want. So here we go. Here's our data. We've got this reaction with two hydrogen iodide molecules forming hydrogen and iodine gas. And we want to know what's the rate equation. So here's our data that we're going to use. And we want to know the rate. All right. What's the rate law? When I say rate, we mean like rate law. I don't mean rate as in these rates. So we have one reactant, and we're essentially solving for the order of the reactant. And the first thing we would do is we were going to find two trials. We only have one. Sorry, we only have one reactant, so it doesn't really matter which two trials we use. We can use any of the. I chose the first two. All right, and then you're going to plug it in, and then I'm going to plug in the rates, and I'm going to simplify. You can see that this thing over here is going to basically be 2, and this is going to be 4 because these exponents are going to basically cancel out. So 2 to what power gives you 4? Well, 2 to the second power. That means that this reaction is second order in regards to hydrogen iodide. So that's how you'd write the answer. All right. Now, this reaction, I've got nitrogen dioxide and carbon monoxide. I want to know what's the rate law. So this is what it would be in general. And once again, I'm solving for the order of these two, M and N. Here's my data. And it doesn't matter which one you choose to do first. I'm going to do nitrogen dioxide just because. And I'm going to look at this, and I'm going to need to find two trials where the carbon monoxide stays the same. You'll notice there's 3 of them. There's one here, the first, second, and fourth trials. It doesn't matter which 2 I choose, right? And then I'm going to plug in my data into my formula. I'm going to choose the first 2 trials, and then I'm going to plug it in, all right? And you can tell the concentration doubled from here to here, and here to here, the rate quadrupled, all right? That's second order, all right? Now, I know this is not exactly 4, but it's really close. So the M here is equal to 2. So the reaction is second order in regards to nitrogen dioxide. Now I'm going to need to do the same thing with carbon monoxide. Which 2 trials were nitrogen dioxide remains constant? There's only 2. That's the second and third. And now you'll notice here that the concentration doubled and the rate stayed constant. So, and I know it's not exactly 0, that means N here is equal to 0. So the reaction is 0 order with respect to carbon monoxide. And here's my rate equation. You wouldn't write it with this in there, and it would just be that. All right. So that's it. And this comes right out of Tro. Thank you. And let me know, give comments or feedback, and let me know if there's anything else I can do to help. All right. Bye.